Hello Puan Mia, this is the video for Engineering Mechanics Lab Report Lab 1 Force Table. This is Group B consisting of me as Amritpreet, Irfan and Haris. First of all, the objective of this lab is to find the equilibrium of one or more known forces using a force table. As you can see in the image that I'm showing right now, this is actually the force table, and then you can see force 1, force 2 and force 3. As you can see in the arrow diagram, there is a resultant force, or maybe you can call that as equilibrium force. Force 1, force 2 and force 3. It depends on how many forces you want to add up to find the resultant force. In this theory, Newton's first law states that an object in a uniform motion will stay uniform, and an object at rest will remain at rest until it's acted upon by an external net force. Measurable quantities can be classified as a scalar or vector quantity. A scalar has only magnitude, as whereas a vector has magnitude and direction. In this lab, it is actually we are finding for the vector force, or maybe the force that has magnitude and direction. Scalar quantities are such as students in class, or maybe the mass of an object, whereas velocity consists of force, direction and acceleration, and vector is usually represented by an arrow where the direction of the arrow represents the direction of the vector and the length of the arrow represents the magnitude of the vector. Two force vectors will determine the third force which will produce the equilibrium in the system. The third force is known as the equilibrium force, and it will be equal as opposite to the resultant force of the two known using force table and work with force vectors. As you can see in this diagram, there are platform which has angle markings in degrees on its surface. Two or more pulleys can be clamped at any location along the edge of the platform. Strings or cords are attached to the central ring, and each string or cord is passed over a pulley and the masses are added to the end of the strings. In this lab report, in this lab, there are equipment and apparatus used is force table. As you can see, this is the force table, and then the set of slotted weights where we'll put at the end here, and then weight hangers where you can see the hook, and then a pulley which should help to control as to redirect the force to act in a horizontal direction, and the tripod stand is to actually to level the circular platform of the sun, and the cord is used to the central ring to connect the weight to the pulley and the weight to the middle key ring. The force table you could use the force table to adjust the direction of the three forces or maybe two forces, and make measurements of the amount of force in each direction and determines the vector sum of the forces. The set of slotted weights is for an easy fixation at the holder, features a hook to make it easier for the experiment use, and the weight hangers is just to hang different weights at different times. So moving on to procedure, the circular platform of the force table is confirmed to be horizontal. The leveling screws were used to make the necessary adjustments as the first step. The second step is two pulleys were clamped to two angles and cords were connected to the slotted weights. The third pulley is connected and slotted weight are added to balance the force. The magnitude and angle of third force was determined after the balance of the forces were done. The magnitude in Newton and the angle in equilibrium force were recorded, and the value of the third force was calculated. The vector of the third and equilibrium force was added to the diagram, and step 2 to step 5 will be done again to calculate different equilibrium forces using different weights and different angles. Each time different weights or angles were used, the equilibrium force was determined and was calculated to its vector force. Each calculation and experimented values of the angle of the third, which is the equilibrium force, was compared to its percent difference between two angle values. That's all from me in the part of objective, equipment and apparatus, theory and introduction, and also procedure. Thank you.
Assalamualaikum and selamat sejahtera. My name is Muhammad Irfan bin Shahrul Nizam. My number metric is 14. DEM 19F1010. Now, I will present the result and the calculation. I will explain the result and calculation for practical task 1, set B. As we can see on the screen, they are given the information of the resultant force on table 1 and table 2. For table 1, the F1 mass given is 90 gram and angle is 112.5 degree. For F2, the mass is 90 gram and angle is 250 degree. For F3, the mass is 70 gram and there is no angle given because it is at equilibrium. The angle action for this table is clockwise. For table 2, F1, the mass is 80 gram and angle is 247 degree. For F2, the mass is 100 gram and the angle is 130 degree. And last, the F3, the mass is 90 gram and angle is 0. The angle action for this table is counterclockwise. Next, we go to the result. On the table result, we use to search the value of the weight and we show the direction force. As we can see, the force we get is we need to change the 90 gram of mass into force value n or n, and we 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 can see the value of force for F1, F2 and F3. Same goes to table 2. We can see the value of F1, F2 and F3. Next, for calculation, for calculation, firstly, we need to change the value of mass into n. After that, we put the value into the formula for force, which is force cos angle for Fx and force sine angle for Fy. After that, we calculate that value until we get the accurate value. After that, we have to search the result. We have to calculate the resultant force value. The formula of this is punca kuasa Fx kuasa 2 plus Fy Cosador, and the value that we get is 64.01 Newton. Sorry for the mistake. Tak letak value. Next, and lastly, we calculate to search the angle, and the formula we use is tan opposite over adjacent, and the value that we get is 88.75 degree. Same goes to table 2. Basically, we use the same formula and calculation to get the value of this table. But for this table, the action angle is counterclockwise. We calculate use the same formula as table 1, but we will get the different value because of the angle action is different with table 1. And the value that we get for resultant force for table 2 is 937.67 Newton. And the angle that we get is 88.22 degrees. Okay, that's all for my presentation for result and calculation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Arif Ramdan. Nombor metrik 14 DEM 19F 1012. So kita bincang pasal discussion. A vector quantity has both magnitude and direction, usually represented by an arrow. So that show the direction of the vector. The length of arrow show the magnitude of the vector in 3 dimensions. A vector direct of the page represent by with a dot inside and vector direct or along the negative z-axis. For conclusion is we gain familiarity in working with vector quantities. We demonstrate the process of several vectors to form a resultant vector experimentally, graphically, and algebraically. We will be able to see difference between resultant force and resultant direction in degrees. The graphical method is more accurate than the experiment method. Possibly source of error include 1. Friction in the pulley, 2. The fact that we ignore the mass of the string, and 3. Error in direction of the force if string will not at 90 degree tangent to the ring. Errors in the direction of the force if the string were not at 90 degrees tangent to the ring would have caused the greater source of error.